Again, so taking a look at this example, we have a trinomial divided by a binomial. So we're not allowed just to simplify like we were in our previous examples, because the highest thing that we can take out of every term is 1. And if we divide by 1, that's not going to change anything. So we have to remember that our fraction bar means the same thing as divide. So we are allowed to rewrite this problem so that we can divide it, and we're going to do that by using long division. So before we get into long division of two polynomials, let's review how to do long division with just a couple of numbers. So remember, when we are dividing, the first number goes inside. So this would be 2015 on the inside of our division. Second number goes on the outside. Okay. So we're trying to decide how many times 3 goes into 2, and it doesn't. So then we go to the 10 spot. So how many times does 3 divide into 20 evenly? And our answer to that would be 6. So I'm going to write 6 at the top. Then we're multiplying. So 6 times 3 is 18. So we write that underneath. And then we subtract. So 20 minus 18 is 2. And then we would bring down the next term. So and then we start our process over. So how many times does 3 divide into 21 evenly? And our answer to that would be 7. 7 times 3 is 21. Then we subtract. So that's going to give us 0. Then we bring down our next term. So how many times does 3 divide into 5? And that is once. So 1 times 3 is 3. We would subtract. We have 2. We don't have anything left to bring down. This number is smaller than what we're trying to divide by, so we would call that the remainder. So our answer would be 671 with a remainder of 2. So we're going to apply that same concept to our polynomials. So again, remember that our fraction bar is the divide, and that it's really grouping the top term and the denominator together. So when we rewrite this using our division symbols, the top part, so the x squared plus 3x minus 40, goes inside, and then our divisor goes on the outside. Now, because we're working with variables, our beginning thought process is going to be slightly different. So instead of thinking how many times does x go into x squared, we want to think of it in terms of multiplication. So what can we take times x to get x squared? And our answer to that would be x. So that's going to be written above. And then we're multiplying. But we have two terms here, so we have to remember to distribute. So x times x is x squared, goes underneath. X times negative 5 is a minus 5x. And then we're subtracting. So because we're subtracting, we have to distribute that to both. So if we switch our signs, and then we can just combine them together. So that's going to cancel. 3x plus 5x is 8x, and then we would bring down the next term and start our process all over again. So what can we take times x to get 8x? So it would be a positive 8. So at the top I'm going to write plus 8. And then we distribute. So 8 times x is 8x. 8 times negative 5 is negative 40. And we're subtracting. So we would switch our signs, and then we're going to combine together. So that cancels. Negative 40 plus 40 is 0. There's nothing left to bring down. So that means that our remainder is just 0. So when we're dividing, our answer to this one would just be x plus 8. No remainder. So if there is a remainder, then we would put r in whatever we have left.